All right. Okay, so this is actually something I forgot to say last time. Here, they state it in the textbook, but we are actually only going to factor, we're only going to factor polynomials with integer coefficients. I mean, you could actually work with polynomials whose coefficients could be whose coefficients are real numbers, complex numbers, or rational numbers. Here, however, we're only going to work with polynomials that have integer coefficients. Makes it a little bit easier for us, actually. Okay. All right. And the technique we're looking at is here, namely, if you actually do have a trinomial, meaning a polynomial with 3 terms. Let me get the laser. As on the top of the slide, as over here. Right? You have a trinomial, it's degree 2, and the leading coefficient's 1. You could try factoring it this way, using this technique, by finding 2 integers, b and d, excuse me, so that capital B, the coefficient of x, is the sum of little b and little d. So you want to find 2 numbers, little b and little d, whose sum is the coefficient of x, whose product is the constant term. That's what really this is telling us. So in other words, you want 2 numbers that fill in the blanks here. 2 integers, that is, not just numbers, integers, whose product is the constant term, whose sum is the coefficient of x. Once you find those numbers, then you can factor this. You can write it as x plus the first number times x plus the second number. You may not be able, though, to find 2 numbers, b and d, where this is true. If that happens, then the polynomial cannot be factored. We actually say it's irreducible. Excuse me, we actually say it's irreducible, but it cannot be factored. All right, so let's do some examples. So let's dive right into some examples. So for the first one here, right, we want 2 numbers whose product is 10 and whose sum is 7. Whose product is 10, the constant term, and whose sum is 7. Now you might think, oh, well, 10 and 1, right? That's going to work. Well, no, it doesn't work. 10 and 1 do not work. 10 times 1 is 10, that's true. But 10 plus 1, that's 7. That's not 7, excuse me. It's 11. So basically, the second equation is what fails. So 10 and 1 are not going to work. Okay, do we give up? No, of course not. Let's try something else. How about 5 and 2? I mean, 5 times 2 we know is 10. And 5 plus 2 is 7. So 5 and 2 are the numbers, the numbers that do work. 5 and 2 are going to work. Okay, that's great. So now what? Well, as I said before, we just put the numbers in. We factor it. Namely, we get x squared plus 7x plus 10 is x plus 5 times x plus 2. And of course, it's good to check. That's what I'm doing here. Right, so we have 5 and 2. We have x plus 5 times x plus 2. And if you multiply it out, you get the polynomial. Okay, so that's pretty good. So that's one example. Are there any questions on that? If not, that's okay. Okay, here's another one. So here, right, we have x squared minus 9x plus 20. So 20 is the constant term. So we want two numbers whose product is 20. The sum is negative 9. The product is 20. Two numbers whose product is 20. The sum is negative 9. Remember, you have to include the minus sign, the negative. You have to include that. You have to. Now, yeah?
Can you just
Yes.
can you just repeat that one that you were just saying about the negative 20?
Oh, no, there's no negative. You want to keep the negative with negative 9. If I said negative 20, I'm sorry. I meant
Oh,
negative
my
9.
bad. Yeah, I heard
Sorry,
negative
not
20.
my
I must
fault.
have heard wrong. My bad.
I could have said it wrong, so it's my fault too. So,
All right.
okay.
Thank you.
But right, you want to keep the negative like negative 9. So,
Yeah.
okay.
All right. Thank
So
you.
what two numbers? That's okay. So what two numbers do that? Well, again, if you were to try 10 times 2, I mean, that's only half right because that gives you 20. I had 10 here. I don't know how I missed that when going over my lecture notes. But 10 plus 2 is not negative 9. So 10 and 2 are not going to work here, right? Because you need both of these equations to hold. So 10 and 2 do not work. 10 times 2 is 20, that's true, but 10 plus 2 is not negative 9. Okay, do we give up? No, we just try something else. We need to find two numbers whose product is 20 and the sum is negative 9. Well, 5 and 4 almost work, right? We know 5 times 4, right? That's 20. That is 20. The sum, 5 plus 4, is that negative 9? No. But you can see we're close though, right? It's 9, but it's not negative 9. Okay, so what do we do now? Well, what if we negate both? That works, right? Negative 5 times negative 4, that's still 20. Sap and sun rules. You know, signs alike, the answer is positive. Signs unlike, the answer is negative. Okay. And for negative 9, negative 5 plus negative 4 is in fact negative 9. So negative 5 and negative 4 work. So what we're going to have then is this polynomial is going to be x minus 5 times x minus 4. That's what we get. And again, you know, I'm just checking here by multiplying. If you happen to write here x plus negative 5 and x plus negative 4, that's fine. It's the same thing. So I actually used to do plus negative, but I think that confused students more. So, all right. So that's what happens in this case. All right. Now, before I let you try some, are there any questions on this? I do expect to do a worksheet today as well, so at least I did with the other class. What's that? Someone have a question or chat? No, thank you. Okay, so let's keep going then. So let me let you try some on your own now. So for this one, we have these three, okay? So again, you're going to factor the same way. For each one, you're going to find two numbers whose product is the constant term, third term that is, and whose sum is the coefficient of x. That's for each of these. Okay, let me stop the recording.